Good morning, students. Now we are going to learn a new concept which is triangle inequality property. In our triangle and its properties, this is another property which is triangle inequality property. So by using this property, we can tell that the given three sides or belongs to the triangle or not. If three sides are given, whether the three sides belongs to a triangle or not, we can judge by using this triangle inequality property. See here, what is this property can be uh, tell by using the two types of the statements. So first one is, you can tell it as the sum property. Second one, you can tell it as the difference property. See here, the sum of the lengths of any two sides of a triangle is greater than the length of the third side. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. To check this property by using this triangle, if you observe here, this is a triangle ABC. Okay. So now in any triangle, the sides can be indicated by a small letter. See here, this is capital A. The side which is opposite to this vertex can be indicated by a small letter A here, and this is vertex B, and the side which is opposite to this vertex can be indicated by small letter B, and this is vertex C, and the side which is opposite to this vertex can be indicated by small letter C here. Here the side small a is equal to 7 centimeters, small b is 6.8 centimeters, small c is 6.7 centimeters is given. Already it is a triangle. Okay. So now this property is satisfying in this or not, you can check here by using these values. So what is the property here? The sum of the lengths of any two sides. If you take any two sides, the sum of these two lengths, for example, if I take A and B, see here what are the three sides A, B, C. If I take A and B, by adding these two lengths, thus that sum will be always greater than the length of the third side. Okay. So here A is equal to 7, I am taking here, this is the first condition, A plus B is greater than C. We can write this property as three conditions, which is first one, if you take cyclically, if you take A, B, C, first if you take A and B, A plus B should be greater than C. Then if you take B and C, B plus C should be greater than A. The sum of the two sides is greater than the third side. If you take C and A, C plus A also should be greater than B. So this is the sum property. So these three conditions should be satisfied to tell that the given three sides belongs to the triangle. Okay, here A equal to 7, B equal to 6.8. By adding you will get 13.8, which is obviously greater than the third side, which is 6.7. This is the C, so 6.7. So first condition is satisfied. All the three conditions should be satisfied. Okay. So now if you take B plus C, B is here 6.8, C is 6.7. 6.8 plus 6.7 is 13.6. This is also is greater than the length of the third side, which is A, which is 7 here. 13.6 is greater than 7. So B plus C is greater than A is also satisfying. Now if we take cyclically, the third condition is C plus A should be is greater than B. Okay, now take C and A. So what are the C and A here? 6.7 and 7. So 6.7 plus 7, which is 13.7. This is also greater than the third side, which is B. Here, which is B, which is 6.8. Okay, now all the three conditions are satisfied here. Since these sides we are taking from the triangle itself, that's why they are satisfying. If you take randomly, that will be different. Okay, that also I will show in the next slide. So first you see to understand why it is how it is satisfying in this by using this condition or not. So this is the sum property. Next, if we take the difference property, that is also triangle inequality property only. Any one of the property you can check whether the given three sides belongs to the triangle or not. So this is also same as this one, but difference we will take. The difference between the lengths of any two sides of a triangle is smaller than the length of the third side. Here the sum of the lengths of any two sides should be greater than the third side. Here the difference of any two sides should be less than the third side or the smaller than the third side. Both are equal, both are triangle inequality properties only. Any one of the property we will use to find that the given three sides belongs to the triangle or not. So here we will check this rule is following or not for this triangle. So checking with the difference rule. So here, what is this rule? The difference of any two sides should be less than the third side. So if we take A, B, C as the three sides, cyclically if we take the difference between A and B should be less than C, which is A minus B is less than C. This is the first condition. Second condition is B minus C should be less than A. This is the second one. B minus C should be less than A. This is second condition. Third one is C minus A should be less than B. So all the three conditions should be satisfied to tell that the given three sides belongs to the triangle or not. So observe here, same values I am taking here. This is A minus B means here, what is the A value here? If we change this, here it is not changing this because something is wrong here. I will show in the next slide. So if you take same value, 7 minus 6.8 is how much here? This is 1.8. So 1.8 is less than the third side, 6.6 here. Okay, less than the third side, 6.6. This I will show in the next slide. So if I see here, here also you can see same. Here I have taken A, B, C values as 5, 6 and 4 in this triangle. Okay, so if you take A and B as 5 and 6, 5 minus 6 is minus 1, which is less than 4. So this is yes, this condition is satisfying here. If you take B and C, B minus C is less than A. So what is the B value here? 6. C is 4. 6 minus 4 is 2, which is less than the third side, 5. So this is also satisfying. S here, this is also satisfying. So C minus A is less than B means what is C here? 4. A is 5. 4 minus 5 is minus 1 you will get. Okay, because it is a negative number. This is also less than the third side, 6. This is also satisfying. Yes. So all the three conditions are satisfying. So this 5, 6 and 4 belongs to the triangle ABC. Triangle ABC. Okay. So if you take another condition, another set of the lengths of the sides, we can observe. So here I am taking A is equal to 3, B is equal to 6 and C is equal to 4. Here also 3, if I take some property here, this is a sum property, this is a difference property. At a time we can observe here. In this screen we can observe all the two properties at a time. So here 3 plus x is 9 is greater than 4. B plus C, which is 6 plus 4 is greater than 10. Here 6 plus 4, which is greater than 10 is greater than 6 plus 4, 10 is greater than the third side, 3 here. So this is also satisfying. Next C plus A, which is 4 plus 3, 7 is also greater than 6. This is also satisfying. So if you take difference rule, A minus B, what is A minus B here? 3 minus 6, which is minus 3 is less than 4. Satisfying here. Next B minus C, what is B here? 6 minus 4, which is 2 is less than the third side A, 3. So this is also satisfying. C minus A is less than B. So C minus A, 4 minus 3 is 1, which is less than the third side B, 6. So this is also satisfying. So here also all the three properties are satisfying. Therefore, the given three sides belongs to a triangle. So if you observe here, Here when I am changing, the lengths of the sides are increasing, and it is showing that the result also showing automatically here like S. So from this it is telling that yes, you can form a triangle, and try to form a triangle by moving the yellow points of the two free sides. See here, just it is increasing, but whether it is able to form the triangle or not, we have to check like this. See here, here you made a triangle. So here you can observe by by adjusting the sides whether it is possible or not. Also practically you can show. Okay, here if I take another set of the lengths here, 4 4 4 I am taking. Since these three sides belongs to a equilateral triangle, here also observe here all are S here. 4 plus 4 is 8 is greater than 4, 8 is greater than 4, 8 is greater. Okay, 0 is less than 4, 0 is less than 4, 0. So it is possible. Yes, you can form a triangle and try to form a triangle by moving the yellow points. Here I am moving the yellow points to form a triangle. So now you can see it. Here triangle is formed. We made a triangle. So if you take another set of the triangle, set of the lengths here, so like this, you see here the second condition is not following here. 7 is not greater than 7, so this is no. So here 4 is not less than 4, no, here it is not following. 4 is less than 4 should have here this number should be less than 4, but it is not following, so it is also no. This is also no. It is equality, so equality is also not possible. They should not be equal also, they should be greater than only. Okay, so now you cannot form a triangle. It is telling that you cannot form a triangle. If you try to form a triangle also, it is not possible. See here, even though we are moving them to form a triangle, they will not form a triangle. Okay, like this it is very difficult to form a triangle. Okay, it is not possible, because here observe here, this is 3 plus 4 is also 7, a is also 7. They will they will coincide like this. We cannot form a triangle, just we can form a straight line like this. This is 3 plus 4 is 7, so it is exactly equal to the length of the third side, which is 7. So you cannot form a triangle, you can form a straight line only by using this. Okay, that's why you cannot form a triangle. So take another length here, take one more example to understand. See here it is 7 I am taking, this is 8, this is 4. See, these three conditions here also satisfying, here also satisfying, so you can form a triangle. So try to form a triangle by moving these two. So you can form a triangle here. So here by moving these two, see here, now you form a triangle. So that's the usage of the triangle inequality property. Here we are telling this property theoretically, whether it is possible or not by testing. These three are the testings. You can use either the sum property or the difference property. Here I am showing both of them simultaneously to understand. You can use any property, any of these two properties to explain that whether the three sides belongs to the triangle or not. Can you form a triangle by using those three sides or not? Okay, so this is the best example to explain this. If I take another one, see, this is the last one. So here a is equal to 7, b equal to 2, c is equal to 4 I have taken, but here these two conditions are failed here. This 6 is greater than 7, it is not correct here, and 5 is less than 4 is also not correct here. So you cannot form a triangle. So by moving this also you cannot form a triangle, because by adding these two, this 2 plus 4, 6, which is less than the third side. Okay, so that's why you cannot form a straight line also like this. You cannot form a triangle. Okay, by moving this, they will not intersect anywhere. Okay, because this is a shortest length, and this is also a small one, you cannot form a triangle. Okay, that's the usage of the triangle inequality property. So by using this property, you have to solve some problem in this some exercise. So now we are going to next very important theorem, which is Pythagoras theorem. So this will be used in your 10th class also. 10th standard, you have a chapter specially based on this Pythagoras theorem, which is trigonometry. In trigonometry, you will use this Pythagoras theorem to find out the heights and distances problems you can solve by using this Pythagoras theorem. Okay, so now you are going to learn about how to find out the third length if two lengths are given in a right angle triangle. Basically, this Pythagoras theorem explains about the properties of the right angle triangle only, not remaining triangle. Only it explains about the right angle triangle only. That's why if you observe the definition of the Pythagoras theorem, it starts the word which is in a right angled triangle. Okay, so it belongs to the, this theorem belongs to the right angle triangle only. So in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. The square of the hypotenuse is equal to the sum of the squares of the other two sides. So before going to learn this theorem, first you have to know the what are the names of the sides in this right angle triangle. So this side is called as this longest side, which is AC. Here if you observe, this is ABC triangle, this is AB, side AB, this is side BC, this is side AC. So this longest side AC is called hypotenuse, and this AB, this vertical side, is called as the perpendicular side, and this horizontal side is, which is BC, is called as the base. This is perpendicular side and this is base, and this is the hypotenuse. And also this base and perpendicular also called as the legs of the right angle triangle also. In some problems we will give that these two are as the legs. L is the leg. This is one of the leg and this is the second leg, and this is hypotenuse only. Okay, this is hypotenuse, this is perpendicular, and this is the base of the triangle. So this is hypotenuse, this is perpendicular side, and this side is called as the base. Okay, these are the names of any right angle triangle, and this base and perpendicular sides are called as the legs also. This is one of the leg and this is another leg. Okay, so this is triangle, right angle triangle ABC. So what is the property here? If you observe, in a right angle triangle, the square of the hypotenuse means the square of the length of the hypotenuse. Square of the hypotenuse means what? Square of the length of the hypotenuse is equal to the sum of the squares of the lengths of other two sides. Squares of the lengths of other two sides means here the square of the hypotenuse means AC square, which is AC square, which is equal to the sum of the squares of the lengths of other two sides. So which is AB square plus BC square. Okay, always it is true in any right angle triangle. In any right angle triangle, always this is true. So the square of the hypotenuse is equal to the squares of the lengths of the other two sides. Sum of the squares of the lengths of the lengths of the other two sides. Okay. So if I take here, observe, I am taking dynamically, we can change these values. So here it is ABs, I am taking 6 centimeters here. Okay, 6. BCs I am taking 9 centimeters. AC is 10.82 is there here. Okay, nearly equal to 11. Okay, 10.82. Okay, now observe here, this is 6 means 6 square. Here what is AB here? 6 square. What is BC here? 9 square, which is equal to this 10.82 whole square. 10.82 whole square or not. See here, this is 6 square means 36 here, 9 square means 81, 10.82 whole square, if you multiply 10.82 into 10.82, you will get 117. So which is equal to 117. Always this is equal. So if I change these values, for example, 1 minute here. Here if I change these values to some other values, so this also will change the next value. 1 minute. Exactly, if we take at a point, we will get integer value. See here, this I am taking 5 here, this 9, this also if I change it to some another value 7. So 5 square plus 7 square is equal to 8.6 whole square you will get here. This is 5 square plus 7 square is equal to 8.6 whole square, which is 74. 5 square means 25, 7 square means 49, which is equal to the 8.6 whole square, which is 74 you will get. Okay, so this is the property here. So now if I take another one, see here, here I am taking, this is 4 centimeters, this is I am taking 9. So 4 square plus 9 square, which is 16 plus 81, which is equal to 9.85 whole square, which is 97. This length will become as the square of the 9.85, which is 97 you will get. Okay, automatically this is changing to 9.85. If I change this, if I change this to some other value, some here 4 and 5, this is 4, this is 5, this will become as 6.4. So if you apply this property, is it correct or not, you can check. AB square plus BC square, which is 16 plus 25. 4 square plus 5 square is 16 plus 25 is equal to 41, which is the square of 6.4, which is the square of 6.4. So this is the Pythagoras theorem. So here in triangle ABC, angle B is here 90 degrees, always angle B is always 90 because it is a right angle triangle, and AC is the hypotenuse here, and AB is the perpendicular side or leg, and BC is the base, BC square. So then AC square is always equal to AB square plus BC square. If you tell it in terms of the names of the sides, hypotenuse square is always equal to perpendicular square, perpendicular side square plus base square, perpendicular side square plus base square. So in any right angle triangle, the hypotenuse is the longest side. Always the hypotenuse is the longest side. Okay, that we have to remember. These two will always be less than the length of this hypotenuse. Always less than this length of the hypotenuse. If you observe here, see here, this is 4, this is 5, these two are less than the 6.4. okay, in any right angle triangle. So this is the Pythagoras theorem. And one more theorem is there, which is converse of Pythagoras theorem. That is also a Pythagoras theorem, but here we are starting the word with right angle. In a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. But in converse theorem, we will tell the same theorem in reverse mode. We will start from this sentence and end with this word, this sentence. Okay, subject will become as object and object will become as the subject, like that. So that property you will see here in the second slide here. Here you see, if the square of one side of a triangle, this one, square of one side of a triangle, if you take the square, that will become as the square. This is nothing but the area of the square. That I will explain later. Why I am showing this figure, I will explain later. If the square of one side of the triangle is equal to the sum of the squares of the other two sides, then That triangle is a right angle triangle. It is ended with this word. That triangle is a right angle triangle with the angle opposite to the first side being right angle. So here I am taking this side as the first side. The opposite to this first side is 90 degrees, which is the right angle. Okay. So now in this statement, it is telling that we are starting from the sides and ended with the statement which is it is a right angle triangle. But in the first property, first theorem, we told that it is already a right angle triangle. In a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. But in hypotenuse, if the square of the hypotenuse is equal to the sum of the squares of other sides, that triangle will become as the right angle triangle. That is the converse. Okay, reversely we are telling. Okay, just that statement we are telling reversely. If the square of the hypotenuse is equal to the sum of the squares of other two sides, then the triangle will become as the right angle triangle. Okay, that is the converse. Means reversely we are telling inverse or reverse, both are equal. Okay, reverse statement we are telling, that is called as the converse of the Pythagoras theorem. Okay, so now observe here whether it is correct or not. Okay, if the square of the side of the hypotenuse, see here what is the square of the, what are the side of the hypotenuse here, see here length, here I will zoom it here to understand here. See here, this is the right angle triangle and this is the hypotenuse, you all of you know. So by using the length of the hypotenuse, I am constructing a square which is having the same length which is hypotenuse. The square which is having the length of hypotenuse. Using this length, with the same length, I am constructing a square here. Okay, then what will be the area of this square here? You can tell me. What is the area of the square formula? What is the area of the square formula? For example, if I take a square here, this is having a side A, all sides are equal, then the area of the square is equal to side square, which is A into A, which is equal to A square. Okay, now this is the square which is having the side length 5.66, then what will be the area of this one? With the side of 5.66 is equal to 5.66 into 5.66, you will get this 32. See here, this is 32. If you multiply these two, you will get 32. So this is the area of this square. This is the area of this square. Okay, so now go to this side. Okay, keep it some equation 1 like that. Okay, go to this side. So what is the length of this side? Observe here, this is 4 centimeters. So by using this length 4 centimeters, we are constructing a square on this side. We are constructing a square which is having the side as 4 centimeters. Then what will be the area of this square? What is the area of this square? You know that area equal to side into side. Here how much is the side here? 4 centimeters, which is 4 into 4, which is 16 centimeters square or 16 square centimeters. This is 32 square centimeters. So keep it like that. This is over. Now take this side. What is this side? This is also having the side which is 4 centimeters. We are constructing a square on this side also, which is having the same length of this leg, same length of this base side. So now this is also having the same area which is 16 centimeters, which is A into A, area of this square also, A into A, which is 4 into 4, 16 square centimeters. Now you have to observe here. So now this is the 16 centimeters, this is also 16 centimeters, this is 32 centimeters. What will you observe here? The sum of these two squares is equal to this one. Okay, the sum of the squares of these is equal to this one, which is 32. 16 plus 16 is how much? 32, which is the length of this square. The square of this length, which is 4 square. The square of this length, which is 4 square is equal to the square of this length, which is 5.66 whole square. Now you can write what is this length? This 4 is AB square. This is AB square. This 4 is BC square, which is equal to this is AC square. So now you got reverse formula. This is AB square plus BC square plus AC square. Now from this you can conclude that this is a right angle triangle. Okay. Since AB square plus BC square is equal to AC square, this is a right angle triangle. Okay. So now why we are taking these squares? Why we are taking these squares? Because we are taking the square of this length. Square of this length is nothing but the area of the square which is formed by the side of this length, which is nothing but this area. And square of this length is nothing but what? Area of the square which is formed by this length, which is 16 centimeter square. The square of this length is nothing but area of the square which is formed by this length. Okay, that's why the area of the square we are telling that 16 square centimeters or 16 centimeter square. That word square we are using because of this reason only. Because of this reason only we are telling that 16 square centimeters like that. Okay, so now we proved that if the square of the hypotenuse is equal to the sum of the squares of the other two sides, the triangle is a right angle triangle. That triangle will be a right angle triangle. This is the converse theorem of the Pythagoras. Okay. Now if you take other triangle, if you take other sides and other triangles, I will show you. Now I am changing the lengths of the sides of this triangle to observe another another example. So here I am taking this as 3 centimeters and this has 3 centimeters, this has 4.24 centimeters. If you observe the area of this square is here, if you observe this is 18 centimeter square, which is 4.24 whole square. Okay, 4.24 whole square. This is AC square is equal to AB square plus BC square or not, you can check here. So AC is what here? 4.24 whole square. What is AB here? This is 3 square. What is BC here? This is also 3 square. So 4.24 whole square is how much here? 18 you are getting. Okay, if you multiply that you will get 18. 3 square means 9. 3 square here also 9. So 9 plus 9 is 18. So it is equal. So that's why since AC square is equal to AB square plus B square, the given triangle is a right angle triangle. Okay, this is the converse of Pythagoras theorem. So by using this, if 3 sides are given, if 3 lengths of the sides are given, by applying this property, if the 3 sides are satisfying this property, then we can tell that the 3 sides belongs to a right angle triangle or not. Okay, this is the use of the converse theorem of the Pythagoras theorem. Next we are going to learn about an important property, which is Pythagorean triplets. These are the important definitions you have to learn to find out the Pythagorean triplets. What is meant by triplet? Triplet means the sequence of 3 numbers. Here in any in any right angle triangle, 3 sides will be there. In any right angle triangle, 3 sides will be there. Those 3 sides will follow this right angle triangle property, which is Pythagoras theorem. If the 3 sides following the right angle triangle Pythagoras theorem, those 3 lengths are called as the Pythagorean triplets. Those three lengths are called as the Pythagorean triplets. So now if we take this definition, three positive integers a, B, C in the same order. So in the same order we have to take what are the numbers they have given, are said to be Pythagorean triplet if C square is equal to A square plus B square. Means it is similar to the Pythagorean theorem. The square of the hypotenuse is equal to sum of the squares of the other two sides. Means, so here this side I am taking it as a hypotenuse, and these two sides is taking that as other two sides. So if the square of this side is equal to the sum of the squares of these two sides, then we can conclude that these three sides belongs to a right angle triangle. Okay, and we can tell that these three sides are Pythagorean triplets. These three numbers are belongs to the Pythagorean triplet. Okay, so for example, if we take the smallest Pythagorean triplet, if we take 3, 4, 5 are the Pythagorean triplet. Are these three numbers belongs to the Pythagorean triplet or not? How can you check that? Take them in a same order. Pythagorean triplet always written in a small bracket, dividing with commas like this, 3, 4, 5. In the same order only we have to take A, B, C. Okay, 3, 4, 5 order only we have to take, because you have to apply this formula. So what is the C here? 5. A is 3, B is 4. So C square is equal to A square plus B square or not, we have to check. So same numbers in the same place, you have to take 5 square, which is equal to A is 3 and B is 4. So by applying this, this is 25, this is 9 plus 16, so exactly equal to 25. So C square is equal to A square plus B square. Therefore the triplet 3, 4, 5 is called as the Pythagorean triplet. So like this, there are infinitely many Pythagorean triplets are possible, we can find, and the methods to form a Pythagorean triplet also it is given in our textbook. So there are two methods. When two numbers are given, you can find out the third number. You can find out the Pythagorean triplets just by using those two numbers. We can find out the any two numbers you can take and you can find out the Pythagorean triplet. Okay, any two numbers you can take, and those two numbers they have to follow this rule. See here, when two numbers are given, if A and B are two natural numbers where A is greater than B, A should be greater than B. Then A square minus B square, first condition is A should be greater than B. In the given two numbers, A should be greater than B. Then A square minus B square is the first number of the Pythagorean triplet, and the second number will be 2 into A into B. This is 2AB. These numbers only you have to take and you have to substitute here. These are the some formulas like. Okay, next third number is A square plus B square. These three numbers are the Pythagorean triplet. If A and B are given, and if A is greater than B, then A square minus B square is the first number, 2AB is the second number, and A square plus B square is the third number of the Pythagorean triplet. See here one example you can understand easily. If A is equal to 7 and B is equal to 4, then you have to find out the Pythagorean triplets by using this formula. And you observe here this 7 is greater than 4. So first condition is satisfying. Next, A square minus B square. What is A here? This is A, this is B. So A square minus B square means 7 square minus 4 square, which is 49 minus 16, which is 33. So this is the first number of the triplet. This is over. Next, take the second formula, which is 2AB. 2 times of A is how much here? 7. B is how much here? 4. So 2 7s are 14, 14 4s are 56. So second number is also over. Third number, which is A square plus B square, which is 7 square plus 4 square. Is 49 plus 16 is 65. So this is the third number. So now 33 comma 56 comma 65 are a Pythagorean triplet. A Pythagorean triplet. Is this set is really belongs to a Pythagorean triplet? How can you check? You have to use this first property. C square is equal to a square plus b square or not. You have to check. Here I have taken 33 and 56 and 65 as A, B and C. So now if you take this c square is equal to a square plus b square formula, you can check that whether the three numbers are belongs to the Pythagorean triplet or not. So 33 square plus 50 square is equal to 65 whole square you will get if you calculate it. Okay. So that's why these three numbers are Pythagorean triplet. So if in any problem they give two numbers and if they ask to form a Pythagorean triplet by using those two numbers, this is the process and this is the procedure you have to use to form the Pythagorean triplet. It's very simple. So first number should be greater than the second number, which is a is greater than b. Then you have to use these three formulas, which is a square minus b square. Okay. So difference of the two squares of the two numbers you have to take, which is the first number. Then 2 into a into b you have to multiply, that will be the second number. Then sum of the squares of the given two numbers you have to take, that will be the third number. Okay. Simply you have to find out just by taking any two numbers. Okay. So this is the method 1. Next method 2. So in any problem only one number is given. Okay, only one number is given. By using that number you have to find out the remaining two sides. This number is the actually this number is the one of the side of the right angle triangle. For example, if it is a right angle triangle, that number may be this side or this side. Okay, you have to find out these two sides. Okay, remaining two sides you have to find out. Okay, one number may. For example, this method of the problems will be questioned to form a right angle triangle by using some base value. For example, if a triangle is having a base 12 centimeters, construct a right angle triangle by using this base 12 centimeters. How can you find out the remaining two sides? You have to use these techniques. Okay, just one of the side will be given. You have to construct a right angle triangle by using this. Remaining two numbers you have to find out which belongs to the Pythagorean triplet. If the given two sides also belongs to a Pythagorean triplet only, you can construct. So remaining two sides you have to find out. So here two conditions are there, two cases are there. What are the case one here? If the given number is even number and if the given number is odd number. For example, if the given number is even number, so for here I have taken 12 centimeters, which is the even number. What is the first step? Step 1 is divide it by 2. Means take the half of the given number, which is 6 here, divided by 2. Means taking the half of the given number 6. Step 2 is take the square of that number. Take the square of the half of this number, which is here 6 square is 36. Step 3 is we have to subtract 1 from that number and add to that number, which is 36 minus 1 and 36 plus 1. That's it. 36 minus 1 is how much? 35. 36 plus 1 is 37. Now you got the remaining two numbers. It's very simple. So 12 is given. First take the half of this number and take the square of that number and subtract 1 and add 1 to that number. By subtracting 1 from that you will get 35. By adding 1 to that number you will get 37. So now 12 comma 35 comma 37 are the Pythagorean triplet. It's very simple. 12 is given, you found these two numbers also, remaining two numbers. So now this will be the 35. Okay, this will be the 37, which is the longest side. hypotenuse, and this will be the perpendicular side. This is the base. Okay, like that you can find out the remaining triplets. If it is a even number, then next case 2 is if the given number is odd number like 13. If the given number is odd number like 13, so simply what is the first step here? You have to take the square of this number. First step is directly you have to take the square of this number. No need to take the half of this number. Okay, directly take the square of this number. Now you have to divide this number equally as the sum of two consecutive numbers. See here, what is the meaning of that? If you divide this 169 with 2, taking the half of this number, 2 8 the 16, 0, 9, 2 4 the 8, definitely you will get 1 here, because it is an odd number, always odd number. By dividing with 2, you will get remainder as 1 here. Remainder as 1 here. Now what is the meaning of 169 here? We are writing it as 2 times of 84 plus 1. 2 times of 84 plus 1, which is 2n plus 1 form. All odd numbers will be in the form of 2n plus 1. All even numbers will be in the form of 2 times of n. Okay. So now this is 2 times of n plus 1. Okay. Now you see here. This is 2 times of 84 means what is the meaning of this? 84 plus 84. We are adding 84 2 times plus 1. Okay. Now if I take this 84 separately and by adding these two, we will get 85. So now this is the sum of 169. You are writing as the sum of two consecutive numbers. Consecutive means continuous numbers, side by side numbers. Okay, two consecutive numbers. The sum of the two consecutive numbers which are nearly equal to. Okay. So now this is 84 plus 85 you are writing. Now that's it. This is the answer itself. So now the remaining two numbers are 84 and 85 only. Okay. So this 84 and 85 will be the remaining two numbers of this triplet. So 13 comma 84 comma 85 is the Pythagorean triplet. Okay, Pythagorean triplet. This largest number will become as the hypotenuse, and these two numbers will become as the remaining two legs. So for example, 13 centimeters base is given. You have to find out the remaining two sides, which are the perpendicular and the hypotenuse. So this is the 13 centimeters. So this will become as the 85 centimeters, and this will be the 84 centimeters, which are these sides of the right angle triangle. Okay. So this is very important in your competitive exams also. So first one is the finding out whether the given three sides are belongs to a right angle triangle or not by using this c square is equal to a square, by applying the Pythagorean theorem only here. By applying the Pythagorean theorem only, we can understand that whether the given three sides are belongs to a Pythagorean triplet or not. So next one is finding out the Pythagorean triplet. Okay, forming the Pythagorean triplet by using the given numbers. First one is these two numbers are individual numbers only, okay, independent numbers only. These numbers doesn't belongs to the sides of the right angle triangle, but you have to use these two numbers to form the any Pythagorean triplet. You can take any two numbers, you can form the Pythagorean triplets. So infinite number of Pythagorean triplets you can form by using this technique. Okay. For example, if I take a is equal to 7 and b is equal to 4, which is a is greater than b, like that. Now by applying this a square minus b square, which is 33, you are getting here 2 into ab, which is 56, a square plus b square, which is 65. So 33 comma 56 and 65 are the Pythagorean triplets, and these numbers will follow the Pythagorean triplet formula also, which is c square is equal to a square plus b square. So now this is only formation of the Pythagorean triplet by using the given numbers. Here, if one of the side of the right angle triangle is given, how to find out the remaining two numbers of this triplet? This is another method. If one of the side of the right angle triangle is given, any length, whatever the length it may be a even number or odd number, any length is given, you can find out the remaining two lengths which belongs to the Pythagorean triplet. The first one, if it is even number, so then you have to make a half of that number and square it and subtract and add 1 to this square number. You will get the remaining two numbers if it is a even number. If it is odd number, take the square of the given number, and that number you have to split into the sum of the two consecutive numbers like this. So this is the procedure. So now those two numbers will become as the remaining two numbers of the Pythagorean triplet. So 13 comma 84 comma 85 is the Pythagorean triplet. So up to now I would like to end this session. In the next session I would like to explain the problems based on this Pythagorean theorem, converse of the Pythagorean theorem, and the Pythagorean triplets. Good day to all of you.